Decoding the cosmos, unveiling the Drake equation. Ever looked up at the night sky and wondered if we're truly alone? The Drake equation is a fascinating tool that attempts to quantify the probability of finding other intelligent civilizations in our galaxy. Let's dive in and explore this mind-bending concept. In 1961, astronomer Frank Drake developed this probabilistic argument to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way galaxy. It wasn't meant to give a definitive answer, but rather to stimulate scientific discussion. It's a framework for organizing our ignorance. The equation was presented at the Green Bank Conference on the Search for Extraterrestrial Intelligence, SETI. It immediately sparked debate and continues to be a subject of intense discussion among scientists and enthusiasts alike. It's a powerful thought experiment. The Drake equation is expressed as n equals our FP NE FL phi FC asterisk L. Each variable represents a factor that influences the likelihood of intelligent life arising. Let's break down each component individually. Our asterisk represents the average rate of star formation in our galaxy. This is a relatively well-understood value based on astronomical observations. It sets the stage for the potential number of planetary systems. FP is the fraction of those stars that have planetary systems. Thanks to exoplanet discoveries, we now know that planets are incredibly common. This variable is much higher than initially thought. NE is the average number of planets that can potentially support life per star that has planets. This is where things get tricky, as we only have one example, Earth. Defining habitable is a complex challenge. FL is the fraction of planets that could support life that actually develop life. This is a huge unknown. We don't know how easily life arises from non-life, abiogenesis. Phi is the fraction of planets with life that go on to develop intelligent life. Intelligence, as we understand it, might be a rare occurrence. Evolution doesn't necessarily lead to complex societies. FC is the fraction of civilizations that develop a technology that releases detectable signs into space. This could be radio waves or other forms of communication. It assumes a desire and capability to communicate. L is the average length of time such civilizations release detectable signals into space. This is perhaps the most speculative variable. Will civilizations destroy themselves or move beyond detectable technologies? The Drake equation is not without its critics. Many argue that the values of several variables are simply too uncertain to provide a meaningful result. It's more of a framework than a precise calculation. The equation also focuses on civilizations similar to our own, which might be a limiting assumption. Extraterrestrial life could be vastly different from what we imagine. We might not even recognize it. Furthermore, the equation doesn't account for factors like panspermia, the transfer of life between planets, or the possibility of life existing in non-planetary environments. It's a simplified model of a complex reality. Despite its limitations, the Drake equation remains a valuable tool. It forces us to think critically about the factors that contribute to the existence of life in the universe. It encourages interdisciplinary collaboration. It also highlights the vastness of our ignorance and the need for further research. It inspires us to explore the cosmos and search for answers to fundamental questions. It fuels our curiosity. The equation serves as a reminder of the potential for life beyond Earth and the importance of protecting our own planet. It underscores the fragility and preciousness of life. It's a call to action. The Drake equation is not just a scientific formula. It's an invitation to explore the possibilities of life beyond Earth. What values would you assign to each variable? What does your version of the equation tell you about the likelihood of finding other civilizations?